to reproduce a spectrum using an assumption that electrons can absorb or emit energy. So Planck was able to reproduce tons of different spectra with different elements, so then that way we could see that elements can absorb or emit different types of energy, certain amounts of energy, and he could get the same spectrum over and over and over again for the same element. That was huge. He did not believe anything that he was doing. He thought that he was so wrong about everything that he did in science. He was the reason that we even started things with modern physics. If it was not for him, we wouldn't have any of this quantum physics stuff at all. Einstein truly developed a lot of his things with Planck's help. So if it wasn't for Planck, we wouldn't have all of this quantum physics stuff, okay? So like it says here, Planck did not believe his own idea. Other scientists, though, used his hypothesis to help explain other scientific phenomenon that classical physics just couldn't explain. And then finally in 1918, Planck won the Nobel Prize, and I mean, he was incredibly baffled, so it's really cool. Going on to slide 8. Einstein, we're going to get into Einstein now. Einstein proposed that not only must the energy be quantized, not only does the energy need to be quantized of something that an electron absorbs or some type of object absorbs. He thought that when an electron emits radiation, that energy must be quantized as well. So Planck really just focused on that when an electron absorbs an amount of energy, that amount of energy has to be a very specific amount. If it's not, it's not going to work. If it's not a certain amount of energy, that electron can't move to a new, higher energy level. Einstein thought if an electron has to absorb a very specific amount of energy, then an electron also must emit a very specific amount of energy to move to a lower energy level, okay? And then he said, Einstein is the one that called this little quantum of energy a photon. And we know that gamma radiation, because we talked about that nuclear stuff during OGT week, we talked about gamma radiation or gamma decay, and that just meant that an element or an atom can emit a photon, which just means like it's a certain amount of energy. It's just like a little pocket of energy. And Einstein is really who coined that term photon, okay? But still, photon energy, we're absorbing and emitting a certain amount of energy. A quantum of energy is the same thing as a photon, okay? So all of those things, all of this stuff just means the same thing. Einstein, though, is the one who really said that energy is only dependent on the frequency of light. And I want us to go back and think about this. Planck said E equals N times H times F, where N stands for your energy level. H is just Planck's constant, which is a constant number that you'll always be given where? The front of your test. And then F is frequency. So Planck saw that, but he never really said anything about it. Einstein is the one who's saying something about it. If you look at this equation, it says E equals H times F. Einstein is saying it doesn't matter what energy level I'm at. It doesn't matter what energy level I'm at because a photon can only hold Planck's constant times frequency, so times F. So that means that must be the amount of energy that an electron can either gain or the amount of energy that an electron can emit. So Einstein is saying that energy is solely based on frequency and then as well as Planck's constant, okay? In the next slide, on slide number 9, we have the photoelectric effect. So Einstein is saying that light can behave like particles rather than like a wave. Huge, huge thing here, because at this time, most people are really spending their time, their money, and their effort in trying to show how light acts more like a wave. For us, we only see really light acting more like waves. We see mostly energy acting more like waves. It's actually, most cases of where light acts like particles are kind of difficult for us to see. And we'll talk about why within these next few chapters. Einstein developed or kind of thought about a concept, the photoelectric effect. Now, we've talked about photoelectric effect before, and the photoelectric effect is just when light strikes a surface and then electrons are emitted. So let's draw a little picture of this. Okay. In my little picture here, this is my light. My light comes down, it strikes a surface. Can it just strike any surface? No, because some of those surfaces aren't going to release electrons. So when we want a really good surface for the photoelectric effect, typically we want a really good metal, and we would call that more of like a photosensitive metal. And that just means that it's able to absorb photons. Okay? So here's my light. It comes down, hits this surface. The light is going to be absorbed by this surface. When it gets absorbed, those electrons are going to leave. So that's why I see this little stream of electrons that's starting to be emitted. So light hits the surface, becomes absorbed, electrons are then emitted, and they're leaving. Okay? This is really just the photoelectric effect. That's it.